Hi guys, welcome to this page of the notes. What we're going to do is another problem here where we're going to graph a quadratic and find the solutions to that quadratic based on our graph. So here we go. Let's just jump right into this. I need to know, right, to set up my XY table, I need to know the value of X where I need to start. And I find that by finding my axis of symmetry. Well, X is equal to negative B over 2A. So let's go ahead and find that axis of symmetry. Yeah, my quadratic is in standard form. I have A, B, and C. They're integers, and it's all equal to 0. So we're all set. We're ready to graph this guy. My B is a positive 2, so a negative times a positive 2 would be a negative 2. My A is a positive 1, so I'd wind up with a negative 2 divided by 2, which would be a minus 1. So I'm going to start my XY table with that value of negative 1. Here we go. I start my table with negative 1. Remember, we're going to go several points in either direction. You only have to do half of it because it'll be mirror images on either side of that axis of symmetry. So negative 1, let's go, let's see here, it'd be a negative 2, negative 3, negative 4. How far did I go? I went to negative 6, negative 5, negative 6. In the other direction, it'd be 0, 1, 2, 3, and 4. Okay, great, awesome. Let's start with my vertex. My axis of symmetry, which is negative 1. And I think these numbers down here are going to be the ones that will be a little bit easier to use. So I'm going to start at my axis of symmetry and go down, knowing that all of these guys up here will just be the mirror image of whatever's on the other side. So here we go. I plug a negative 1 into my equation. Negative 1 squared would be 1. Negative 1 times 2 would be a negative 2. So 1 minus 2 would be a minus 1. And then negative 15 would be a minus 16. Again, remember that that represents my vertex. Let's keep going. I plug in a 0, 0 and 0. Those terms all drop out. Minus 15. Again, mirror images, so whatever the 0 is, the negative 2 will get me the exact same thing. Again, you don't have to take my word for it. Try it. Go ahead, plug a negative 2 in there. I promise you, you'll get a minus 15. And I know what that is. Anytime x is 0, you're crossing the y-axis. This is my y-intercept. Right? Because the x is 0, I must be crossing the y-axis. Let's keep going. I plug in a 1. 1 squared is 1. 2 times 1 would be 2. That would get me 3. 3 minus 15 would be a minus 12. Mirror images. So if this is a minus 12, that's a minus 12. Let's do 2. You plug 2 in, and I believe, let's see, 2 squared would be 4. That would also be a 4, which would give me 8. 8 minus 15 should be a minus 7. Okay, plug in 3. 3 squared is 9. 2 times 3 would be 6. 9 and 6 would be 15. 15 minus 15 would be 0. All right, so there we go. I have just found my x-intercepts. Whenever y is 0, you cross the x-axis. X-intercept, x-intercept. And one more, let's just see what happens. If I plug in a 4, you wind up getting 9 and 9. All right, let's go ahead and graph these points and see what my parabola looks like. Let's graph some points that fit. This one doesn't fit, doesn't fit, doesn't fit, doesn't fit, doesn't fit. This one does. 2 minus 7, 1, 2, 1, 2, 3, 4, 5, 6, 7, right there. And negative 4. 1, 2, 3, 4, minus 7 right there. Those both fit. Minus 5, 0, minus 5, 0, and 3, 0. And 4, 9, 4, 9, and negative 6, 9. Negative 6, 9. All right, my axis of symmetry was at negative 1. Let me throw that in there real quick. I didn't ask you for it, but we'll throw it in there. And my parabola, if I were to graph it, would look something like this. Again, my vertex is going to be somewhere down here on my axis of symmetry. You don't have to complete the graphing. And again, if you're taking this class with me, when I give you a test, you will be able to fit your quadratic on the coordinate plane I've given you. That's why we're doing this one together in the notes. On a test, your quadratic, your parabola will absolutely fit on the coordinate plane I'll give you. We'll see a couple more examples here in a second. But anyway, that's what the graph would look like. I just plot the points that fit, connect the dots, and you can start to see that parabola. Again, it makes perfect sense that it opens up because my A is positive, and that means that it would open up. I've got all of my information right here that I would ask you for. If I ask you for the roots, negative 5, 0, and 3, 0. If I were to ask you for the vertex, negative 1, negative 16. And if I were to ask you for the y-intercept, there it is, 0, minus 15. Let's go ahead and head over to the next page of the notes and try one more of these. Since we're getting pretty quick at them, we can fly through this one as well. Again, remember, I need to set up a chart. But to set up that XY table, that chart, I need my axis of symmetry. All right, so X is going to be equal to a negative b over 2a. Well, first let's make sure that I'm in standard form. I am not in standard form. Remember, in order to be standard form, it must be equal to 0, and a, b, and c must be integers. So let's go ahead and fix that by adding the 12 to the other side, and I have x squared minus 8x plus 12 is equal to 0. Now I'm in standard form and I can figure out my A, my B, and my C, and this guy will be much easier to graph because it's in standard form. Well, my B is a minus 8, so negative times a negative 8 would be a positive 8. My A is a positive 1, 2 times 1 is 2, and so what I wind up with is a positive 8 divided by 2, which would be 4. So I'm actually going to start my next XY table or chart at x equals positive 4. All right, so there's my 4. Now I just need to go a few in either direction. It looks like I did 4, 3, 2, 1, 0, negative 1, and then 4, 5, 6, 7, 8, and 9. Okay, let's go ahead and jump right into these. I'm going to plug a 4 in for my values of x. 4 squared is 16. 4 times a negative 8 would be a minus 32 plus 12, and you wind up getting a negative 4. Don't fat finger something on your calculator. And I know that this is my vertex. Keep going. Plug a 3. 3 in for, I'm going to go this way because these numbers are going to be a lot easier to do than these numbers down here. As far as mental math goes, 3 squared would be 9. 3 times a negative 8 would be minus 24 plus 12, and you wind up getting a minus 3. And since it's mirror images, 5 would also be a minus 3. Plug in a 2. 2 squared is 4. 2 times a negative 8 would be minus 16 plus 12, and you get 0. So now I know, right, whenever y is 0, I have found my x-intercepts. And let's keep going. If I plug in a 1, 1 squared would be 1. 1 times a negative 8 would be a negative 8 plus 12, and you wind up with 5. 5 and 5. Plug in a 0. Those terms drop out. I'm left with a positive 12, which actually doesn't even fit on my graph. So I would stop there, but I do know whenever x is 0, that represents my y-intercept. All right, let's go ahead and plot these points and see what our graph looks like. My vertex is at 4, negative 4. 4, 1, 2, 3, 4, right there. Then I'm at 5 minus 3 and 3 minus 3. Then I'm at 2, 0, 2, 0, and 6, 0. I would then be at 1, 5, 5, and 7, 5. And those are the only points that fit. My next point is 0, 12, which actually doesn't fit on the coordinate plane I've given you. Draw your parabola by connecting the dots. Feel free to put that axis of symmetry in there as a dotted line if you would like. Again, I didn't ask it for you, but if I had asked you for it, it would run right there. And I am always going to ask you for the roots, which would be 2, 0, and 6, 0. I will always ask you for the vertex, 4, negative 4. I will always ask you for the y-intercept, which is at 0 and 12. Guys, now we've done a couple of these problems as far as finding the solutions of a quadratic by graphing. Now, the 3 that we've done so far are actually fairly simple, straightforward. They do get a little trickier. So, head on over to the next page of the notes. We'll take a look at some trickier ones. I'll meet you guys there.